Okay, this is Geometry Chapter 1, Section 3. This is Example 2. I'm going to be finding the distance between 2 points on a coordinate plane. So the first thing I'm going to do is plot my 2 points. I don't really have to do this, but I'm going to just for this example. So this is going to be -4, +1. So -4 is the x direction, +1 is my y direction. So there is point E. And then my second point is 3, -1. So I'm going to go forward 3 and down 1, so 3 in the x direction, -1 in the y direction, and that is point F. Oops. There we go. There's point F. Okay, so those are the 2 points that I want to find the distance between. Using Pythagorean theorem, hopefully you remember Pythagorean theorem from previous years. Let me grab let's go with a green line. I'm going to go over and down to F, and my distance is going to be this blue line going across here. So I want to find the distance of F, and this is basically Pythagorean theorem. I've drawn a right triangle, so I have a squared plus b squared equals c squared, where, oops, this is A, this is B, and the hypotenuse is C. Okay, so A, if I count over, that's going to be 1, 2, 3, 4, 5, 6, 7. So A is equal to 7. And B is 1, 2, so B equals 2. And so I'm going to fill this in. So I have A is 7 squared plus B is 2 squared, and that's going to be equal to my C squared. So 7 squared is 49, 2 squared is 4, and so that's going to be equal to 53. And 53 is C squared, so C squared equals 53. And the opposite of squaring is square rooting, so to get that by itself, I square root that and I square root this. And so C is equal to, I say the square root of 53 because it's not a perfect square, like 49 or 64. So final answer there would be, using Pythagorean theorem, this blue distance here is the square root of 53. If I use the distance formula, so here is, let's go, this is going to be x1, this will be y1, this will be x2, and this will be y2, okay? My first point, my x and my y coordinate, my second point, my x and my y coordinate. Let's fill them in here. So x2 is a 3, so I want the square root of x2, which is 3, minus x1, and x1 is a -4, so minus a -4 squared, plus, I need the y2. y2 was a -1, so I put the -1 in there, put my minus sign, and y1 is a +1, so I put my +1 in there. Okay, now I need just to do the math here. So -3 minus a -4, so -3 plus 4 is 7 squared. And -1 minus 1 is a -2, and that's going to be squared. I forgot my little square right there. And I square root it, and you see we're exactly kind of where we are right here, 7 squared plus 2 squared, and then I would have to square root to get rid of that square here. So 7 squared plus 2 squared. So this is going to be 49 plus 4, square rooted, and so I again end up with a square root of 53. So you can use a Pythagorean theorem and get the square root of 53, or you can use the distance formula and get the square root of 53. Both get you there, and you need to be able to use both depending on the situation on which one's going to be easier for you. So one more time through the distance formula. So I'm just going to do distance formula and not Pythagorean theorem on this one. So D is equal to the square root of, and we did x2 minus x1 squared, oops, equals the square root of, let's go, x2 minus x1 squared. And then the formula, if you recall, it's a plus sign here, minus signs in here, so the subtracting them and then adding them together. So plus y2 minus y1 squared. Okay, so this is my x and my y coordinate on my first point, and this is my x and my y coordinate on my second point. So this is equal to the square root of, and let me put all my markers in here. And just fill in my numbers. So x2 is a 1, right? x2 is 1. x1 is a negative 3. y2 is 2. And y1 is a 4. Okay, so it's 1 minus a negative 3 and 2 minus 4. Okay, doing the math, 1 minus a negative 3, so that's 1 plus 3. 1 plus 3 is 4, so that's 4 squared. And 2 minus 4 is negative 2, so negative 2, and I'm going to square negative 2. And all of that's supposed to be square rooted. So that becomes 16 plus 4 square rooted, which is equal to the square root of 20. And this year you're going to be expected to do one more step here. 20 isn't a perfect square, but I can break that down into the square root of 4 times the square root of 5. 4 times 5 is 20. 4 is a perfect square, so this is actually 2 square roots of 5, and that's what we're going to be doing this year with your answers, is writing them in this final form, this 2 square roots of 5 final form.